Welcome back. Now that you're developing a feel for judging how well your models are performing, it's time to supercharge them. We've seen that when fitting a linear regression, what we're really doing is choosing parameters for the model that fit the data the best. We also saw that we had to choose a value for the alpha in ridge and lasso regression before fitting them. Analogously, before fitting and predicting k-nearest neighbors, we needed to choose n neighbors. Such parameters, ones that need to be specified before fitting a model, are called hyperparameters. In other words, these are parameters that cannot be explicitly learned by fitting the model. Now herein lies a fundamental key for building a successful model, choosing the correct hyperparameter. The basic idea is to try a whole bunch of different values, fit all of them separately, see how well each performs, and choose the best one. This is called hyperparameter tuning, and doing so in this fashion is the current standard. There may be a better way, however, and if you figure it out, I'd be surprised if it didn't make you famous. Now, when fitting different values of a hyperparameter, it's essential to use cross-validation, as using train test split alone would risk overfitting the hyperparameter to the test set. We'll see in the next video that even after tuning our hyperparameters using cross-validation, we'll want to have already split off a test set in order to report how well our model can be expected to perform on a dataset that it has never seen before. The basic idea is as follows. We choose a grid of possible values we want to try for the hyperparameter or hyperparameters. For example, if we had two hyperparameters, C and alpha, the grid of values to test could look like this. We then perform k-fold cross-validation for each point in the grid, that is, for each choice of hyperparameter or combination of hyperparameters. We then choose for our model the choice of hyperparameters that perform the best. This is called a grid search, and in scikit-learn, we implement it using the class gridsearchcv. We import gridsearchcv from sklearn.modelSelection. We then specify the hyperparameter as a dictionary in which the keys are the hyperparameter names, such as n neighbors in KNN or alpha in ridge and lasso regression. See the documentation of each model for the name of its hyperparameters. The values in the grid dictionary are lists containing the values we wish to tune the relevant hyperparameter or hyperparameters over. If we specify multiple parameters, all possible combinations will be tried. As always, we instantiate our classifier. We then use gridsearchcv and pass it our model, the grid we wish to tune over, and the number of folds that we wish to use. This returns a grid search object that you can then fit to the data, and this fit performs the actual grid search in place. We can then apply the attributes best params and best score respectively to retrieve the hyperparameters that perform the best, along with the mean cross-validation score over that fold. Now, it's your turn to practice your new grid search cross-validation chops. You'll also learn about randomized search CV, which is similar to grid search, except that it is able to jump around the grid. Happy grid searching.